Hi Year 9, Year 9, you're Year 10, keep making that mistake. Welcome to your weekly introduction videos. This week we're going to learn about circle theorems. So we've already done most of this, so it's recap. But very, very important topic, one where you can pick up quite a lot of marks and I think for you, easy enough, okay? So here's a starter question for you to do. The circle to the right with centre O has a diameter of 20 centimetres. Perimeter of the triangle OAB is 36 centimetres. Calculate the area of the triangle OAB. Okay, so stop the video and have a go yourself. Okay, hopefully you've done that. So it's just a matter of understanding the language being used here. So what we should know is that actually this and this are both the radius of the circle. So it's an isosceles triangle. And since they're both the radius, with the diameter is 20, the radius is 10. So we know those two lengths are each 10. And if the perimeter of the entire triangle is 36, then this length here must be 16. And since it's an isosceles triangle, what I can do is I can split this down the middle, because remember, area of a triangle is a half times the base times the height. Well, I already know a half. I already know the base of this triangle is 16. What I don't know is the perpendicular height. Well, I do know that half of the base is 8. So I've now got a right-angled triangle where I know the hypotenuse, I know one of the shorter sides, and the other short side is the height. So the height squared must be equal to the square root of 10 squared minus 8 squared, which is the square root of 100 minus 64, which is the square root of 36, which is equal to 6. Okay, so the height of the triangle is 6. So now the entire triangle's area must be a half times the base, which is 16, times the height, which is 6, which is 3 lots of 16, which is 48 centimetres squared, and there is my final answer. Okay, hope that makes sense. So what I'm going to do now is I'm going to go through the 7 circle theorems that you have to know. And the clue's in the name. This is all about angles made from facts about circles. Okay, so these are all angles with inside circles. Now the first rule you need to know, and this is how you describe the rule. So if somebody says to you, give a reason, here is your reason. Angles from the same chord are equal. Okay? And what we're doing here is we're looking for a bow tie. If I can make a bow tie where the tips of the bow tie touch the circumference of the circle, then it is a fact that the tips are the same angle. Okay, so we're looking for a bow tie. Let me just show you this on GeoGebra. So here I've got a bow tie situation here. It doesn't matter where I put my tips, the angles are always the same. So blue ones are 48, those tips are equal, and the red ones are 44. They're equal. If I move things around, the red ones are still 44, and the blue ones have moved to being 23. Move them around again, blues are still 23, reds have changed to 13, but they're always equal. Okay, so those tips of the bow tie are always equal. So that will allow us to answer a question like this. So stop the video and see if you can do it yourself. Find angle P, Q and R. Okay, P should be very easy. P is equal to 27 degrees, and give a reason. Angles from same chord are equal. So we always write down in brackets the reason why that is the case. Q is equal to 29 because it shares with the other tip. Okay, that's the same reason. Angles from same chord are equal. Now, what's R? Hopefully that's very easy for you because you know it's a triangle. Interior sum of angles in a triangle equal to 180. So it's just going to be 180 minus 27 minus 29. And so R must be 124 degrees because the sum of interior angles of a triangle is 180 degrees. Okay, so don't forget the normal rules of angles that will come into play to help you. Okay, so that's the first rule of circle theorems that you need to know. Okay, here is the second rule. The angle at the centre is twice the size of the angle at the circumference. So if we take an angle from a chord both to the middle and then to the circumference, then the angle at the middle is going to be twice as big as the angle at the circumference. Okay, again, let's just look at that on GeoGebra. Where's that one? Angle at the centre. Why is that not working? Angle at centre. Okay, so again, it doesn't matter where I put this tip. Okay, the angle at the edge is always half what it is at the centre. And I can change that angle. So if I change that to 80, then the one at the circumference changes to 40, and it doesn't matter where I put it. Now, what I say with this one, the hint is look for an arrow. Okay, look for an arrow. But it's not always an arrow. Sometimes it looks like this. And it kind of looks like a bow tie now. But this is what I would call a broken bow tie. This is not a real bow tie because in this instance, not all 4 points are on the circumference. 3 of them are, and the other is at the centre of the circle. So that is also the same issue. Okay, you can see there the angle at the circumference is half what it is at the centre, no matter where I put it. Okay, so that's what we look out for. You've got an example here because they're all stemming from the same chord. Then you're getting the same answer. So this angle is 15 and this angle is 15 because they're both half of what it is at the centre. Okay, so here's a question for you to do. Nice and easy, I think. Stop your video and do it. Okay, very, very easy. A is equal to 61 degrees. And B is equal to 61 degrees for the same reason. Angle at centre twice angle at circumference. So in brackets, always write in your reasons. Okay. Now the reason why I gave you this question is because certain angle rules prove other angle rules. As what you notice, if that is 61 degrees and that is 61 degrees, we've actually proved rule number 1 because this is a bow tie. And we said the tips of the bow tie must be equal. So you've just used that as an example to prove the first rule. Okay. Right, one more rule and then we'll stop and go to part 2 of the video. Okay, rule 3, the angle in a semicircle is always a right angle. So look for a triangle where the base is the diameter of the circles. It has to go through the centre. Has to go through the centre. Otherwise it wouldn't be making a semicircle. And if that is the case, we always get a right angle from the angle that we make from the diameter. Let's look at that on GeoGebra. Angles in a semicircle. you can see here, no matter where I put my angle, it's always 90 degrees. And I can move the diameter so that it still goes through the middle, and I'm still always getting 90 degrees as long as the base of that triangle is the diameter of the circle. Okay, so hopefully that one is easy. Okay, so see if you can find angles X, W, X, Y and Z here. What we're going to have to start doing is combining some of the rules. Okay. Right, the first one you can do here is W will be equal to 15 degrees. Now why? Because angles from the same chord are equal. That is to say, here we have a bow tie. Okay, we have a bow tie. So therefore, this angle must be the same as this angle. Okay, X is equal to 90 degrees because what we have here is a a diameter with an angle made from the diameter, and that's always 90 degrees. So we can say angle in semicircle is 90 degrees. Okay, what's Y? Well, we've got a triangle there. We've got a triangle, and the sum of interior angles of a triangle is 180 degrees. So I'm simply going to do 180 minus 90 minus 15. Let's just write that down. 180 minus 90 minus 15. And that is equal to 75 degrees. Now it's very important that you understand that what I've done there is a calculation, not a reason. You have not given a reason yet. The reason is interior angle sum of triangle is 180 degrees. That's a reason. This is a calculation which you need to give. This is a reason, okay? And Z, don't forget your most basic rules. Z is 105 degrees because angles on a straight line are 180 degrees. Okay, nice, easy stuff.